Okay, question 11. Find the points on the parabola y equals 6 minus x squared that are closest to the point 0, 3. Okay, now there are two ways to do this, but because of a limited familiarity with the distance formula here, what we're going to do here is just a slightly different approach. It also happens to be a faster approach. So first of all, just take a look at this. The parabola is going to look like this. Okay, and then we got the point here 0, 3. And here's our parabola y equals 6 minus x squared. And we want to find the points along the parabola that are closest to this point right here. Well, that's going to occur at some point B, let's say. So this is point A. At some point B, where the line connecting it is going to be perpendicular to the tangent line. Okay? So basically the shortest distance is along the perpendicular. If you come out here, it's definitely not the shortest distance because, well, basically because the angle that you meet the tangent line at is going to be way less than 90 degrees. So that's what we're looking for here. So I don't know what the coordinates of B are. I might call it x comma y, but I can do better than that because I know that y is equal to 6 minus x squared. So this is x comma 6 minus x squared. So now I can figure out an expression for the slope of the line segment joining A and B. That is going to be, okay, y minus 3 over x minus 0. But I know that y is, in this case, 6 minus x squared minus 3 all over x minus 0 is just x. And so putting those together, 3 minus x squared over x. Okay, so that's my expression for the slope based on the 2 points that I've got here. I know that this should be perpendicular to the slope of the tangent. Well, the slope of the tangent, okay, the slope of the tangent is going to be, well, take the derivative of the parabola here. That's going to be negative 2x. Now, these should not be equal to each other because they're perpendicular. What should happen here is the slope of the tangent line should be equal to the, and I'll think back to Math 10, the negative reciprocal of the slope of that line. Okay, that's how we get the perpendicular, by using the negative reciprocal. Okay, now what I would do with this is, well, I would notice from this expression right here I could cancel the negatives to start off with. And then what I might do is multiply up by the 3 minus x squared. So that's going to get me 6x minus 2x squared equals x. Yeah, I'm kind of lazy here. I think what I'm going to do, I'm sorry, that should be x cubed, 2x cubed. I'm going to bring those guys over to the other side here. So I'm going to make that 0 is equal to 2x cubed minus 5x. Take out the common x, and I'm left with 2x squared minus 5. So my solutions here are going to be x is equal to 0 or plus or minus root 5 halves. Well, now the real question becomes, well, where on earth am I getting the minimum out of this? I want to know the point closest to the given point here. So what I want to do here is take a quick look at how this derivative is behaving here. Now, remember, this is my expression here for the slopes. I've brought everything over. I've set it equal to 0. So really what I want to do here is figure out, okay, what I've done here is think of it this way. I've got this expression for the slopes. I've put them together, set it equal to 0. So this is looking for where it's maximized or minimized. That's what that's doing. What I want to do here is just investigate what this is doing all on its own here as a cubic. Its roots are negative root 5 over 2, 0, and positive root 5 over 2. The way I've got it sitting on this side of the expression, this is a positive cubic, so it's got to be doing this. Okay, which means it's negative here, so that means the original function is decreasing. Positive here means it's increasing. Negative here means it's decreasing. Positive here means it's increasing. Think about what that means. That means this right here is a minimum. The 0 is a maximum, and then this one here is a minimum again. Okay, so it turns out this is that 0 is just a local maximum, and so my mins occur at plus or minus root 5 over 2. And if you plug both of those into the original expression for the quadratic, the 6 minus x squared, in both cases you're going to get 7 over 2. And so those are the points that minimize the distance.